So now we're going to look at forming ionic compounds and trying to name them and write the formulas. So an ionic compound is made up of a cation and an anion. So something like sodium chloride. Sodium is a cation, the chloride ion here, this is the anion. And overall it has a net charge of 0. So if you go back and you look at where sodium is on the periodic table and where chlorine is, sodium's over here in +1, so we know that that's sodium +1. The chloride ion over here is -1. So for every positive charge, we have a negative charge, and so +1 -1 equals 0. So ionic compounds are always going to add up to 0. They're not going to have a charge. For every I need the same number of positive pieces as I have negatives. So since sodium is +1 and chlorine is -1, it's just a 1-to-1 ratio, so I just get NaCl. So how do I write the formula of an ionic compound? The cation is always going to go first. So the metal, so remember ionic compounds are metal plus a nonmetal, metal plus a nonmetal, or a polyatomic ion, or a polyatomic cation plus a polyatomic anion. First we'll just start off with like metal and a nonmetal, or metal and a group of nonmetals. You write the metal first, the cation first, the guy that's downstairs. If you have the name, the metal's always going to come first. So just as you have it written here, write the elements in that order. And then what you want to do, the hard part, is to figure out what kind of subscripts do you have. Where do I put these subscripts, if I need any at all, in order to indicate how many of each type of element I have, or each ion I have, and make sure that they add up to 0 overall. And so if you only need one ion, then omit the subscript. If you have a polyatomic ion, you have to enclose the whole thing in parentheses. So we'll see where that goes. But let's just take magnesium chloride. Let's do some baby steps. Magnesium, let's see, what's the charge on magnesium? So if you have the periodic table in front of you, this is really helpful. This is where magnesium is, +1, +2. So magnesium has a +2 charge, and the other element that we're looking at is the chloride ion again, which has a -1 charge. Remember, ignore the noble gases. So this is -1, -2, -3. So chloride ion is -1, magnesium is +2. So I'm going to put that right above it. Magnesium +2 because it's in column 2. The chloride ion is -1 because it's one of the halogens. And so if you think about what we have here, I want to get this to be neutral. I can't just write MgCl because magnesium has a +2 charge and chlorine has a -1 charge, and the positives don't balance out the negatives. So let's think about that. Let's think about what it kind of looks like. So if I have a magnesium +2 ion, and I have one chloride ion over here, I need one more chloride ion in order to make this add up to 0. So this would have a +2 charge, and then I'd have 2 of these, and each one has a -1 charge, so overall I get a -2 for my negative side. +2 -2 gives me 0, and now I have a neutral compound. Right? So you could draw these pictures every single time, or you could do this crisscross rule. So in order to figure out what your subscripts are, the subscripts are the ones on the bottom, in order to figure out how many magnesiums do I need for how many chloride ions, what you do is you write the charges up on top, right? This is +2, and this is Cl-, and then you crisscross them. I take this is -1, I put a 1 down here. This is +2, I put a 2 here. I don't have to put the charges on the bottom because I know that this guy is positive, this guy is negative. That's why they're going to get together. I'm never going to have 2 positives, I'm never going to have 2 negatives. I'm always going to have a cation and an anion. And so my final answer, instead of writing Mg1Cl2, if there's a 1 there, I don't write anything. So I just ignore that 1 subscript on the bottom. If nothing's there, I assume that's 1. Cl2. So the formula for magnesium chloride is MgCl2. So all I did was take this superscript, cross it down here. This superscript, cross it down there. MgCl2. And this is why it works, because magnesium has a +2 charge, and now each one of those chloride ions has a -1 and a -1. So overall, that ends up being negative. My positive things cancel out my negative things. So let's try aluminum oxide. One more thing. In your final answer, you don't want to have any charges, right? Ionic compounds are neutral, so make sure if you're doing this crisscross thing, you scribble out the charges, or you just rewrite it. Aluminum. All right, so let's look up the charge on aluminum. And oxide is just this just came from oxygen. See how these all end in "ide"? If they end in "ide", it came from the periodic table. It's a non-metal in the periodic table. If it ends in "ate", it's a polyatomic ion. Or if it ends in "ite", it's a polyatomic ion. So let's see. Who do we have there? Aluminum. So we have +1, +2, and then +1, +2, +3. So aluminum has a +3 charge. And then -1, -2. Oxygen has a -2 charge. So aluminum has a +3 charge. And oxygen has a -2 charge. So now all I'm going to do is crisscross this. I have aluminum, and I have aluminum, and I have oxygen. I have a 2 up here on the oxygen, so I'm going to cross that down here and put the 2 next to the aluminum. I have a 3 up here on the aluminum. I'm going to cross that down. So now I have 3 oxygens. So if you think about, a picture that goes along with this, I'll draw it over here. 2 aluminums, that means I have aluminum and aluminum. And each one has a +3 charge. And then I have 3 oxygens. O, O, O. -2, -2, -2. So that's this 2 really means I have 2 aluminums, and this 3 means I have 3 oxygens. Now I have +3 and +3, that gives me a +6 charge, and -2, -2, -2 is a -6 charge. So +6 -6 gives me a 0, so this is neutral. So this is going to work almost every single time doing this crisscross method. So I go to barium. Barium has a +2 charge. Nitrate, that's one of my polyatomic ions. That's NO3-, so that's up in the table. Do the same thing now. I'm going to crisscross. I have barium, and I'm going to write nitrate. Nitrate was 1, so I have a 1 down here. It's a phantom 1. I don't even write that one. And now, since I want 2 nitrates, I have to put that in parentheses. If I just put a 2 here, right, that looks like I need 32 oxygens, which is not what I want at all. So if I want more than one of this ion, I have to put it in parentheses and then put the indicate the subscript outside. So this means I have barium 2+, and then 2 nitrates. That's NO3- and NO3-. So I have -2. This was a +2. So that's neutral. So make sure if you have a polyatomic ion, you put the whole thing in parentheses and then indicate if you need more than 1. Only put a parentheses around it if you need more than 1. Calcium hydroxide. So calcium's a group 2. So go back on your periodic table, you can see calcium's in group 2. Hydroxide has a -1 charge. Hydroxide, this is an ion. This is a polyatomic ion. That's in the table of things we have to memorize. So we have calcium, and then to write hydroxide, I want 1 calcium, and then 2 hydroxides. So see how this is a -1. I need 2 -1 charges to give me a -2 for every +2. Now potassium nitrite. Nitrite. We didn't talk about nitrite. We know that we have nitrate. Nitrate is NO3. That's nitrate. And it turns out to go from nitrate to nitrite, and this is always going to work, to go from an 8 to an 8, you just get rid of 1 oxygen. So nitrite is NO2-. So that's a little trick. We can go over that again. So nitrite looks like that. Potassium's here. So potassium nitrite is just KNO2. I don't need any parentheses. I only need 1 and 1. Like this is a +1 charge, that's a -1 charge. I only need 1 to 1. That's good. So whenever you want to go from 8 to 8, just get rid of 1 oxygen. This is nitrate, this is nitrite. What else did we have? This was phosphate. So this is phosphite. I just get rid of 1 oxygen to go from 8 to 8. That will work with any of the polyatomic ions. Barium phosphate, so barium 2+. Phosphate, that's one of our polyatomics. 3-, so we'll crisscross and we get Ba and then PO4. Now, how many bariums do I want? 3, and I want 2 phosphates. So barium, each one is +2, so that gives me a +6 charge on that side. Phosphate is -3 times 2 gives me a -6 charge, so that makes that neutral. So that's always going to work.